question is about complex numbers. On a sketch of an Argand diagram, shade the region whose points represent complex numbers z satisfying the inequalities. The modulus of z plus 2 is less than or equal to 2, and the imaginary part of z is greater than or equal to 1. So first of all, you see the modulus of z somewhere and only on one side. This is a circle, the locus of a circle. To find the center of the circle, we gotta make it in the form of z minus z1. So z minus something, but make sure when you open up the brackets, you get positive 2, and this is just 0, so you get exactly the same as the original question. So from here we can see the center is minus 2, 0, and the radius is from here, the radius is just 2, and smaller than means we shade inside the circle. So you don't have to sketch this, but to visualize things, I'm doing it separately. We have to label the x-intercept, y-intercept, center of the circle. And for this locus, so imaginary is like the y-axis. So this is y is greater than 1. Y is greater than 1 means, this is the y equals 1 line. Of course, it's crossing this y-intercept 1. So greater than means we shade above this horizontal line. Okay, so we combine the two loci. We shade inside the circle but above the line. And label everything. Label essential features of the graph. Now part B, find the greatest value of arc z. Arc z means the theta, the angle. So the z is the complex number, and this complex number is like a line from the center of the circle. So this is the center of the circle to any point in this area, in this shaded area here. So we need to use a line from the origin. So a line from the origin, so from the origin to any point in the shaded region. So that is the z. Now since we need the arc z to be the greatest, we need the angle to be the biggest. And that is when the line is from origin to this point around here, which is this point which is touching the region. So this is the theta or the arc z we are looking for. Now how do we find the arc z? Well, we can find this angle here first. If we know this angle, we can just do pi minus or 180 degrees minus. Now to find this angle, we're gonna need some trigonometry. So we're gonna need this length and this length if you look at the triangle. So now let's focus on finding the lengths. Now if we redraw this triangle here, we draw the triangle. Yeah, I'm just gonna find this angle actually. I'm just gonna find this angle here. I'm calling it alpha. So this angle here is alpha. So we already know that this distance is 1. We already know this is 1. And tangent alpha is therefore, well, we're gonna need to use this yellow triangle first actually. Okay, so just focus on this yellow triangle. So if we look at this yellow triangle, again this distance is 1, this is 1, and we know that this is the radius of the circle, and the radius of the circle is 2. So using Pythagoras, we can find the other side, which is root 3. So we know that this length is root 3. So now that we know this is root 3, and of course this is the radius 2, then the total length, this total length here would be 2 plus root 3. Okay, so 2 plus root 3 would be this distance, root 3 plus 2. So this is also root 3 plus 2. 2 plus root 3, this is 1. Tangent equals opposite over adjacent. That's why we have tangent alpha equals 2 plus root 3. And the alpha is therefore the inverse tangent. And for the argument, we need to use this alpha plus 90 degrees. So 90 degrees is pi over 2 plus alpha, and use calculator in radians, we get the final answer 2.88, or you can use exact value actually. So exact value 11/12 pi. Alright, I'll see you again next time.